we're picking up where we did yesterday, or where we left off yesterday on standard deviation, and we're looking at variance, and we're going to be drawing some bell curves. And what we're going to do today is we're going to draw a bell curve pretty much with every example, not every single one, but anyone that's asking anything related to z-score, standard deviation, mean, we're going to draw a bell curve. And I think that's going to help you see the picture. How many of us will admit we're visual learners? You can see it and you understand it a lot better. Maybe? Maybe. I think most of us are. All right, so we're going to draw a bell curve and answer the following questions. If the girl student's average shoe size is an 8 with a standard deviation of 1. So when I say average shoe size, what's average? It's the mean, okay, and it is 8, and it has a standard deviation of 1. So I'm going to draw it on the next page. Don't worry about the questions for right now. Let's just draw the bell curve. Okay, so in the middle is our mean. What's our mean? 8. How many deviations will we have to the right? Always. 3. You'll have 3 to the right and 3 to the left. Sometimes you might see a fourth one, but why will you most of the time only see 3? Well, between 3 is how much of our numbers? 99% of our numbers. Remember those percentages? So why don't we need like 4, 5, and 6 deviations? Because if you got 99% of your numbers within 3, then, you know, you might see a fourth one, but it would pretty much be useless because 99% of your numbers are going to be within 3 standard deviations. Okay? You got almost every single number in those 3 deviations. You with me? So we're going to think on the bottom, this is like a number line. +1, +2, +3, -1, -2, -3. And I'm going to tell you that these numbers are going to be like your z-scores. They are the number of deviations you are away from the mean. So if I'm at 2, then that means I am 2 deviations away from the mean. Does that make sense? 2 steps away from the mean. Now, I told you yesterday, how can we know where I'm sitting at right here? The size of the gap is what we're going to consider our standard deviations. It tells you how many shoe sizes or how many points or how many inches, whatever you're talking about, in this case shoe sizes, each gap is. So our standard deviation is 1, right? Our standard deviation is 1. So if this gap is 1, which means if I'm sitting on 8 and I take 1 step to the right and it's worth 1 shoe size, where am I at now? In a positive direction, I'm at 9. And then again, this one would be 1, so I would be sitting at 10, and this one would be 1, which means I'm sitting at 11. Okay? If I go 1 step in this direction, I'd be sitting at size 7. If I go in this direction, I'd be at size 6. And if I go in this direction, I'd be at size 5. Would you agree with me that pretty much 99% of our shoe sizes are going to fall between size 5 and size 11 for girls? We don't know many girls that have bigger than 11. Maybe-ish. 1. Again, it's not 100% because you got that one person that might have a really large foot, and not many girls have below a size 5. Okay? You with me? Not many. You might have that, 0.2% that might have that below that. Okay? All right. So let's answer. Now that we have this, let's answer some questions. Okay? First of all, I want to know what percentage of shoe sizes are within 3 standard deviations. That means within 3 steps to the right and 3 steps to the left. So we've already talked about this. Here's your 3rd step to the right. Here's your 3rd step to the left. How many of our numbers are going to be between these? 99%. Okay, now let's review from yesterday. What if I said what percentage is within 1? One step this way and one step this way. Let's review really quickly. 68. So again, more than half of our people would fall between a size 7 and a 9. And let's just look at that with our girls that we have here today. How many of you fall in between a size 7 and a size 9? Would you agree that more than half of our girls? I got 1, 2, 3, 4, 5, 6 that fall between that. And totally I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6 out of 9 of us fall between a 7 and a 9. Is that more than half? If we have 9 girls? Yeah, it is. So it generally works that way. What if I want to know how many, what percent of girls fall between a 6 and a 10? That's 2 to this side and 2 to that side. Nope. 95%. So most of us would fall between a 6 and a 10. Okay? 99%. You need to know those percentages, and you need to have those memorized. And it's like that every time. Will it always be 68%? All the time between one standard deviation. Okay? Will it always be 95% between 2 standard deviations? Will it always be 99% between 3? And that's ish. Okay? Roughly around 99%. Okay? All right. My second question, so the answer to this one would be 99%. Okay? My second question is, what is the z-score of 6.5? 6.5. Now, look at where 6.5 falls. Can you tell me, where does 6.5 fall? Between 6 and 7. So can you tell me what the z-score is going to be? Negative 1.5. So look at what the picture's already answered it for us. It's negative 1.5. But if you don't want the picture, some of us will like the picture and some of us will like the formula. So we have this beautiful formula that we looked at yesterday. Z equals x minus mu divided by the standard deviation. So I'm looking for the z-score. X is my specific data. In this case, which specific data value am I referring to? 6.5. I want to know about 6.5. That's the specific one I'm talking about at this point in time. Minus the mu, which is our mean. Which one's our mean? 8. Divided by our standard deviation, which is 1. So what is 6.5 minus 8? How about negative 1.5? Divided by 1, what's negative 1.5 divided by 1? Negative 1.5. So didn't y'all tell me that it was going to be negative 1.5? You sure did. See, the picture can tell us, but the formula can tell us as well. Okay? How about what's the z-score if the value is 8? 0. You are on the mean when you are at 0. Okay? Could we put it into the formula? Yes, you could. Z equals, what's our specific data value that we're talking about? 8 minus the mean, which is 8, divided by the standard deviation, which is 1. What is 8 minus 8? 0. 0 divided by 1 is 0. Okay, so it gives it to you either way. Do you see that we're doing it 2 different ways? We're looking at the picture. We're looking at the formula. Okay, but either way, we'll give you the same answer. Sometimes you need to know the formula, because what if I said, which they don't really have shoe sizes that aren't in halves, but what if I gave you like I want to know the z-score that follows a 9.2. Do you know, where is 9.2? It's in between 1 and 2, but do you know exactly? You'd have to use the formula to get the exact decimal point. Now, how did we know? Everybody says, well, this was in between. How did you know it was exactly 1.5, negative 1.5? Because 6.5 is exactly in between, right? Huh? Yes, but you see what I mean? Sometimes you can't. Sometimes it's hard to see. So sometimes you'd have to use formula. Bad example. This is an easy one because they're only going up by ones. So what if you're going up by decimals? Does that make sense? And sometimes they do go up by decimals. Okay, and we'll look at more of those today. All right, let's move along. So I have 3 questions here for you. Come on. Good morning. You brought me breakfast. Hmm. Feel the love there. Feel the love. Yeah. We're going to find the mean, the variance, and the standard deviation. And I'm going to give you, and I'm going to tell you an easy way to do it. We're going to do it in our calculator. Okay? So, finding the mean is not that big of a deal. What would I do with all those numbers to find the mean? Add them up and divide by how many we got. But to get the standard deviation and the variance, it's a little more complicated because it's a pretty much, you got to subtract this and square this and add this and subtract this and square this to each one of those things, and it's pretty long. So we're going to do it in our calculator. Is that okay with everybody? My numbers. Okay, so first thing that we are going to do is we're going to go to stat. Okay, statistics. Does everybody see the stat button? Yes. And we're going to edit. And we're going to enter our list. Okay, L1 stands for list 1. L2 stands for list 2. Does everybody have L1, L2? Because sometimes if your settings are messed up, you might have like L3, L4, L5. You need to make sure you're in list 1. Okay? Okay, so if your L1 has stuff in it, you're going to arrow up to where L1 is highlighted. Does everybody see that? And you're going to hit clear, and then you're going to hit enter, and it should clear it out. Okay, so we're going to put in 11, we're going to put in 12, we're going to put in 12. You got to put them in even if they duplicate them. 14, 16, 16, 16, and 19. And I'm going to count this. You see at the bottom where it says L19, that means I'm on the 9th row, which means how many have I put in so far? I've put in 8. If I'm on the 9th row where it's blank, then that means I've put in 8 before that. So 1, 2, 3, 4, 5, 6, 7, 8. I always double check, make sure, because sometimes we miss them, right? It's okay. We'll get it. Okay, so from here, let me wait. Macy, you tell me when you're good. Quit. Okay, let's go to stat. You're going to go back to stat. This time we're going to calculate. Okay, so we're going to arrow over. You see where it says edit? And if you arrow to the right, it'll say calculate. Okay, from there we want to calculate one variable statistic. So we're just going to hit enter. And we're going to hit enter again. And it gives us a whole set of numbers. Okay? You got to hit enter, enter. Twice. 3 times for y'all. So if you're listening to this at home, Sydney and Morgan, you're going to have to, on your calculators, you're going to have to enter several times. Okay, Kelly says 3. Kayla says she had to hit hers 4, twice, 7 times. So hit enter, 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 enter till you get it to where you have it now. Now, what do you recognize about some of these things? Do we recognize any of those symbols? Yes. The first one is an X bar. Do we know what X bar means? Mean. Okay, remember yesterday I told you mu was mean, but X bar was mean as well? Well, in our calculator, they use X bar. Okay, so we know the mean is 14.5. Okay, so we can go ahead and write that, 14.5. That's your mean. Do we recognize any other of those symbols? Do we recognize SX and do we recognize sigma X? Okay. S means standard deviation of the sample. Do you remember that? Sigma means standard deviation of the population. Now, what did I tell you? Which one? And we're going to use for today, we're going to use, on these types of problems, we're going to use the one they use on the SOL. Which one did I tell you they use on the SOL? The sigma, the bottom one. So we're going to round it to the nearest tenth. Let's just round to the nearest tenth for today. So we're going to use this bottom one, which would be 2.5. Okay, we're going to use the bottom one. So that is our standard deviation. So notice you have to find your standard deviation. Is anywhere on there the variance? No. What did I tell you I wanted you to remember about the variance? It is the It's the square standard deviation. So if you know the standard deviation, I want you to know that the variance is the square of that for now. Okay? And don't ask any more questions because I could spend an entire semester teaching you just about statistics. So I'm only going to give you what you need to know. So all I need you to know about variance for right now is that once you find the standard deviation, all you got to do is square it and it'll give you the variance. Okay? So the last big one. Okay? Now, in a couple days, remember this, I'm going to show you something, a sneak peek. Do you remember in elementary school how you found for your box and whiskers, because I told you we had to do box and whiskers in a couple days, and you had to either put in stem and leaf or you had to list it in least to greatest, then you had to find your lowest value and your highest value and your median, and then you had to find your lower quartile of your median and your upper quartile of the upper part. Do you remember those 5 points to make your box and whiskers? Well, watch this. Use your arrow and go down. Do you know what the min, Q1, median, Q3, and max are? These are the points. All you got to do is it's right underneath. These are your quartiles. This is your lowest value. This is your first quartile. This is your median. This is your third quartile. And that is your highest value or highest extreme, whichever way you called it. But your maximum. Those are your 5 points. So the second quartile is the median. It's the same thing as, you don't have one. When I go over box and whiskers in a couple days, you'll see it. But just know we are going to put it in our calculators and go to statistics, one variable. We're going to calculate one variable statistics. When it pops up, it's all this stuff, but where is our information for box and whiskers hiding? Underneath it. Okay, so we'll show that to you in a couple days. Isn't that nice to know? So for our purposes here, we know the mean is 14.5. Does it make sense that our average is 14.5? Yeah, it's close to the middle. You with me? We know the standard deviation rounded to the nearest tenth is 2.5. How do I figure out the variance? Square it, which would be 6.25. So there's your 3 answers. Okay? Questions on that? Easy enough? What's the question? You didn't square it correctly. Try it again. Emily, help him. Sydney and Morgan, we are missing you. Dylan is lost without you. Exactly. Okay. So let's look at 7. Is that where we're at? Are we at 7? Okay. All right. So we're going to do the same thing here. We're going to do several of these just to practice. Okay, I would write the numbers down, and then I'd put mean, variance, standard deviation equals. Okay? Don't click the square root button. Square it. Okay, so we're going to go back to stat, and we're going to hit enter. We're going to edit. Now, I told Dylan a minute ago, what happens when you can't just go delete? Well, I guess you could, but that would be a lot of work to delete all those and then put all the other ones in. So if you want to get rid of that list all in one, Shazam. Then you're going to arrow up to L1 to where it's highlighted. You're going to hit clear and then enter. Bam, your list is gone. Does everybody understand that? Then we are going to put in 2.3, hit enter, 4.7, hit enter, 5.8, hit enter, 7.7, 9.8, and 10. And I always double check, again, go back and make sure if you have 6 numbers that you have 6 numbers entered in. What happens if you forget one number or you miss a decimal point or you make a flub? Your numbers are going to end up wrong. So make sure you get them in just so. Okay? Now that the list is in, where do I go to get my stuff? We go back to Stat. We're going to go over to Calc. And we want the first one. We want one variable statistics. So we're going to hit enter, enter, or enter, 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 however many times you have to enter. Okay? So in this case, what is our mean? 6.7. We're going to just round everything to the nearest tenth for today. Okay? Which, can I find the variance on here? No. You know SX is standard deviation of the sample. You know that sigma x is standard deviation of the population. We're going to use the same one for the SOL. I'm going to keep telling you that so you'll know which one to use for the SOL. So which one are we using? The one at the bottom, which is 2.8. So we have 6.7 for our mean, 2.8 is our standard deviation. How can I find the variance? Square 2.8, which would be 7.84. Now, let me ask you some other things. If you have all this information, if you have the mean and the standard deviation, could I draw a bell curve from here? Could I answer questions about z-scores from here? You follow? You could do a lot of different things from here. Okay, you could answer anything. All you need to know is the mean and the standard deviation, and you can draw a bell curve, you can answer z-scores, you could do lots and lots of different things from there. Okay, and the way we find this is you take your data and you put it in your calculator and you go to your statistics. Okay, all right, you try, 8, that's where we want. You try this one on your own. An E. It's a summation symbol, and you'll learn that in Algebra 2. Like I said, I could spend a whole semester, a whole year teaching you about statistics. I had a whole class that was just on this stuff. Okay? All right, so what's our mean? 9. What is the standard deviation? 3.8. What's the variance? 14.4? 44? 44. Okay. So 14.4 or 14.44, depending on where you round to. Okay. All right. You ready for an example? This won't be. I just want to ask you this to see what we can do, and then I'm going to show it to you. So let me actually take this information. But are you ready for some candy? All right. This is for candy. Let me get my notebook up. Come on. Yeah, you're going to use this information. So I'm going to tell you, your mean is 9, right? Your mean is 9. Your variance was what? 14.4. And your standard deviation is 3.8? Okay. So my question to you, and this is just for Kenny, it's not an example, but you can add it onto your notes. You might want to use it. You can put it under the same one. How about that? I want to know what data value has a z-score of, let's go 13. What data value has a z-score of 13? Sorry, let me change this. Sorry, thinking off the top of my head. Let me go, has a z-score of 2.5. So the first thing that I would do, the minute it's talking, you got mean, you got standard deviation, and they're asking for z-scores. And so the first thing, which a lot of you did, was do what? You drew bell curve. But here, we got to be careful about what pieces and parts we have. So, what goes here? 9. Okay, 1, 2, 3 to the left, 1, 2, 3 to the right, 3 to the left. This is a 0, 1, 2, 3, negative 1, negative 2, negative 3. Okay? Now, how big is our step worth? It's worth 3.8. A lot of you only did 1. Why did we did 1 on the last one? Because the standard deviation was 1. This time the standard deviation is 3.8. That is how big your step, how big the gap is, okay? So, if I go 3.8 from 9, where am I? Where am I? Where? 12.8. How'd you get 12.8? You just add 3.8 to 9. Does that make sense? So, if I take another step in this direction, how much is that step worth? 3.8, which would be 16.6. If you go another direction, it's 3.8, which is 20.4. So I saw some people taking a 2.5 step. No, the step is not worth 2.5. I'm wanting to know what the z-score of 2.5 is. So I'm saying 2.5 is one of these things down here. Okay, so tell me, where's our answer going to fall? It's got to be in between these two numbers, right? Because 2.5 is in between. Now, here is a good example of, do we know what is exactly in between? Now, you could do what to 16.6 and 20.4 if you want to know what's exactly in the middle. You could find the average. You could add them up and divide by 2. But what we normally do if you don't see it is we use the formula. How many put something into the formula? Okay, so z equals x minus mu divided by standard deviation. Now you have to be very careful of where you plug things in. What do we know? Do we know the z? Do we know the z-score? Yes, we do. Z-score of 2.5. We have been given the z-score in this case. I have not been given the data value. I don't know one of these things. I've been given the z-score. So I'm going to put a 2.5 for the z. Do you understand that the z-score is 2.5? Because it tells us that the z-score is 2.5 here. I want to know what data value, which variable represents the data value. That's what I'm looking for. Which variable is the data value? If I want to know the specific data value, which one of these variables is the data value? No, what's the mu? What's the mu? Please stop. What's the mu? The mu is the mean. What's the standard? The sigma is the standard deviation. What's the x? The x is the specific data value. So when this says, what is the data value, I'm going to be solving for the x in this case. Does that make sense? So if they give you the z-score, you got to plug it in for the z. If they give you the data value, which they had done in the other examples, I gave you the data value, right? You plugged it in for the x. Minus the mu, which is what is our mean? 9 divided by the standard deviation. What's our standard deviation? 3.8. Now, we have to solve for x. So, you have to go back and know how to solve an equation, which we should know how to do. What's our first step? Parentheses? No. Fractions? Do we have fractions? Yes, we do. How do we get rid of our fractions? Multiply by the denominator. So I'm going to times this by 3.8, and I'm going to times this by 3.8. If you wanted to, you could have divided and conquered and did x over 3.8 minus 9 over 3.8, but you're still going to times by 3.8. What is 3.8 times 2.5? 9.5. What happens to the 3.8 here? They cancel, and you're left with x minus 9. How do I get x by itself? Move it over. 9.5 plus 9. So what's x? 18.5. Does it make sense that the z-score is 2.5 and that the data value would be 18.5? It'd have to be in between here. Okay? Yes? We'll look at more of those. Let's go back. Let's finish our notes. Okay. So, this one says we are going to, this is our last example. We're going to draw a bell curve and answer the following questions. If the student's mean height is 64 inches, welcome, with a standard deviation of 2 inches. Okay, so can I draw a bell curve? So I want you to practice. I want you to go ahead and draw the bell curve for me at this time. Okay, all you need to know to draw the bell curve is what? The mean and the standard deviation, and you can fill in the whole bell curve. So go ahead and draw a bell curve at this time. Change one of the questions, so don't worry about the questions real quick. So if I'm going to draw this, in the middle is our mean, which is 64. You got 3 to the right and 3 to the left. So how big is my step? 2. How do you know that? That is your standard deviation. So if that gap is 2, this is a 66. And if you, to get that, you just add 2 to 64. So this gap is 2, so that would be 68. This gap is 2, which would be 70. In a negative direction, this would be 62. This would be 60, and that would be 58. I encourage you, please go ahead and draw your 0, 1, 2, 3, and your -1, -2, -3, because you'll need to associate that with your z-scores. Okay? So, question number 1. What percentage of students' heights are within 2 standard deviations? 95%. Within 1, that's 1, when it says within 1, that's 1 step to the right and 1 step to the left. Okay, you with me? So I look at it within +1 and -1 is 1 standard deviation. Between +2 and -2, 2 to the right and 2 to the left, that's 2. So 68 between 1, 95% of numbers are within 2. How many would be within 3? 99%. Okay? All right. What z-score is associated with a data value of 62? So I have been given the data value in this case, right? So this one's pretty easy. Can we see it with the picture? What z-score is associated with the data value of 62? It's -1. Okay, if you wanted to do the formula, you could. Okay, in this case, number 3, what z-score is associated with a data value of 67. This one's pretty simple to see because it's going to be 1.5, but if you didn't know it, you would have to use the formula. Just reviewing that. Do you know the z? Are you looking for the z? You're looking for the z. Do you know the data value? 67. Do you know the mean, the mu? 64. Do you know the standard deviation, which is 2, and then you just work it out. 67 minus 64 is 3, and 3 divided by 2 is 1.5, which is what y'all told me, that it would be in between there, which would be 1.5. So sometimes you need the formula, sometimes you don't. Question, I'm going to add a question. Question number 4. Okay, question number 4. Let me write it down here. What data value has a z-score of negative 1.7? What data value has a z-score of negative 1.7? Figure that out for me. You want it for candy? What data value has a z-score of negative 1.7? Got to work it out. First of all, okay. Yoo-hoo! Yoo-hoo! Tell me first of all, where is negative 1.7? Because I'm giving you the z-score in this case. Where is negative 1.7? Negative 1, negative 2. So my data value is going to be somewhere between 60 and 62. So when you give me an answer of 67, you know you're definitely wrong because it's got to be somewhere between 60 and 62. I think. Yeah, okay. So here we go. Let me take a look at this. First of all, if I look at my formula, you've got to plug in. They may give you the z and give you the mu and the standard deviation and ask for the x. They may give you the x, the mu, and the standard deviation and ask for the z. They might even give you, I've seen some, that they give you the z, check this out, they give you the x, they give you the mu, and they ask you to find, and I see that they give you the variance and ask for the standard deviation. If they give you the variance, all you got to do is take the square root of it. Okay, but I've seen where they've given you all of this, and they ask for the standard deviation, and then the question says, what's the variance? You have to square, you got to find this and then square it. Okay, so they might give you, they will give you, you got 4 variables up there, right? You need to know how many of them to solve. You need to know 3 of them. They will give you any 3 and ask for the missing 4th. And you should be able to find any of those. And we'll look at those and look at more of those as we go on. So in this case, have I been given the z-score? Do I know the z? Yes, the z is negative 1.7. Do I know the x? The x is the data value. No, it's asking for what data value? Okay, so I'm looking for the x. Do I know the mean? Yes, the mean is 64. Do I know the standard deviation? 2. So I got to solve for x. So what would I do to solve for x? I'm going to multiply by 2 first, get rid of my fractions. You're going to go back and follow your rules. Parentheses first, fractions next. When I times 2 by negative 1.7, I get negative 3.4. Okay, the 2's cancel here, and I get x minus 64. How do I solve for x? If I'm subtracting 64, I can just pick this up and move it and add 64. So when I add 64 to both sides, I come out with 60 So does it make sense that it's in between there? Does it make sense that it's closer to 60 than 62? Why? Because negative 1.7 is closer to 2, so it's going to be closer to this side anyway. So it would be 60.6. Okay? Questions? All right, so let's take a look